Okay, today we're going to finish up our 6-4 to 6-6 notes. So we are in section 6.6, and we're on problem 6B. So this is in the very last page of notes, 6B, and we have -1 plus root 3i, and we are going to raise that to the 5th power. Now, we did one of these last time, and it took quite a bit of effort, so we got to go through step by step. So the very first thing we're going to do is to change this number into polar form, or trigonometric form. So what that means is we have to find r and theta for this number. So you'll remember what that involves is drawing a picture. I'm going to go left 1 and up root 3. And then here is r. And then this is one of those tricky ones where you have to be on the lookout, because this is going to be my theta. Okay? Now, if you are really engaged right now, if your mind is really sharp, you're going to recognize that triangle. You have a 1 and a root 3. That radius is going to be 2. That r is going to be 2. And this angle is going to be 60, because 60 is across from the root 3. Now, if you know that, then you just go with it. Do not think you have to show a bunch of work. You don't need to. If you're not sure about that, where all that came from, then remember, to get r, we square the first one, we square the second one, we add them together and take the square root. So that gives me an r value of 2. And then the tangent of that angle, I'll call it A, is root 3 over 1. So I will second tangent root 3 over 1, which is root 3. And when I type that into my calculator, it says 60 degrees. So if you recognize that triangle, that's one of your special right triangles, then you don't have to do all this work. If you don't recognize it, then here is the work that you would go through to find your r and to find this angle, which is not theta. Be careful. Theta will be the green angle, which will be 180 minus 60. So theta is 120 degrees. So now we have figured out that our r value is 2 and our theta value is 120 degrees. No, we aren't done. We're not even close to being done, okay? So now what I'm going to do is, I'm going to erase all this so I have room to work. And I'm going to write my number now in polar form. So now my number is 2 CIS 120. And that is the number that I'm raising to the 5th power. At this point, gang, all you have done is rewritten your number that's in rectangular form or complex form. You've rewritten that into polar form. Now we have to raise it to the 5th power. De Moivre's theorem says, and we talked about this the other day, De Moivre's theorem says we take the radius to the power, so we're going to take 2 to the 5th, and then there's our CIS. We're going to multiply the angle times the power. So De Moivre's theorem, very, very simple theorem, very powerful, but very simple to use, says take the radius to the power, take the angle times the power. So 32, 2 to the 5th is 32, and 120 times 5 is 600. So you have your calculator, go ahead, take 2 to the 5th, and then 120 times 5. Now, we ran into this last time. That angle is too big. So you're going to have to shrink that down. Do you remember how to do that? Do you remember what we do when our angle is too big? Yep, we subtract 360. So take 360 away from that. 600 is more than a revolution. We do not want an angle that is more than a revolution. So if we got one, came out because we multiplied 120 times 5, but now we have to reduce it, and it goes down to 240. That is the answer in polar form. This is my polar form answer. Now remember, the directions to this section said we had to answer in complex and polar. So that's part of the answer right there. That's the polar form answer. Now we need a complex answer. So we need an answer that looks like this. We need an X and a Y. Okay? So remember, I keep writing it down. X equals R cosine theta, and Y equals R sine theta. So keep in mind, your R is 32, and your theta is 240. So X will be 32 cosine 240, and Y will be 32 sine 240. All we're doing is rewriting the answer that we got in a different form. So we're using our conversion equations to take this R and theta and get it in an X and Y form. So 32 cosine 240 is negative 16, and 32 sine 240 is negative 27.71i. Remember, the I always goes with the Y, so it'll always go with your sine value there. So negative 16 minus 27.71i, and that is the other answer to the problem. So we got a couple of answers. This one is in polar form. This one is in complex form. Okay, there's a lot to that for sure. Let's try the next one. We're going to do the same thing with the next problem, which is root 2 minus root 2i, and we're taking it to the third power. Okay. All right, so hopefully you can look back up at your, the one we just did, and remember what you need to do first. The first thing you need to do is to change this number into polar form. We need to change this number into polar form. So that means we need to find R, and we need to find theta. That's what polar form is. We need to change it into this. So we need to find an R and find a theta. So we'll draw a picture. So it's over root 2 and down root 2. Okay, we need to find R. And we need to find this angle first. And then ultimately, we're going to find theta. This is going to be theta. Okay, so to find R, we square the first one. So root 2 squared is just 2. Square the second one. Root 2 squared is 2. Add them together and take the square root. So R is 2. Remember, when you square a radical, all that cancels and you're just left with that guy right there. So root 2 squared is 2, root 2 squared is 2, add them up, you get 4, and the square root of 4 is 2. Now, some of you can probably tell me without doing any work that if that's a root 2 and that's a root 2, this angle is going to be a 45. Because anytime these two match, anytime opposite and adjacent match, x and y, anytime x and y match, you're going to have a 45-degree angle. But if you didn't see that, didn't remember that, you know that the tangent of that angle is opposite over adjacent. So if you second tangent, that's just 1. If you second tangent 1, you're going to get 45. Now, what does that make theta, though? Please do not put 45 here. That angle is not 45. How big would that angle be? That angle would be 360 minus 45. So that angle is 315. Now, if you're thinking you're done, whoopsie, not even close. Because all we've done so far is rewrite our number into polar form. We still need to cube it, guys. We haven't done that yet. We haven't done this part yet. We need to cube it. So to do that, we remember de Moivre's theorem says we take the radius to the power, so that's going to be 2 cubed, and we take the angle times the power, so 315 times 3, which is 945. Don't forget you have a calculator if you need it. So it's 2 to the third, and then 315 times 3. So I have 8 CIS now, 945. That's what we get. You don't have any mistakes there. But 945 is way too big. So what did we say we were going to do when the angle that we got, when the theta that we got was bigger than 360, more than a revolution? What did we say we were going to do? Yep, we're going to subtract 360. So I'm going to take 945 and subtract 360. Oh my. Did you get 585? That's still too big. Do you see that? 585 is still too big. So guess what we're going to do? We're going to subtract another 360. And we get 225. When your angle is too big, and when I say too big, I mean more than 360, you're going to subtract 360. And you're going to keep subtracting 360 until you get one finally that's smaller than 360. So we took 945, took away 360. It was still too big. So we took away another 360 and we got 225. This is the polar form of our answer. Remember the directions said answer in complex and polar. So now I need the complex form of the answer. Now remember, complex means x plus yi. Complex means x and y. Complex, rectangular, all that means x and y. So I'm not writing it down again. I've written it down several times. I've asked you to highlight it in your notes. How do we find x? X equals r cosine theta. And here's my number, and this is r, and this is theta. I'm taking my polar form answer. There's r, there's theta. and I'm going to find the x and the y that goes with that. So x is r cosine theta, and y is r sine theta. So my complex form looks like that. So 8 cosine 225, negative 5.65, actually 6.6 if I round it off, and 8 sine 225, same thing, only that one gets the I. And there is the complex form of the answer. So here is our polar form, right here, and there is the complex form. Okay, we have one more of those to do. These are by far the most complicated problems in this little unit. But they're all done exactly the same way. So if you're taking good notes, you should be able to follow along just fine. All right, so our number, our last one, negative 2 root 3 minus 2i, and we're going to raise this one to the 6th power. So the first thing we're going to do is change this guy into polar form. So we're going to change this into polar form, RCIS theta. So that means this is x, this is y. We have to find r and theta. So we'll draw ourselves a little picture. Now pay attention to the signs. That's how I need to be down here. I'm going 2 root 3 left, 2 root 3, and down 2. This is x, this is y. Left and down. Now I need to find r and angle A. I always need to find the angle inside the triangle at the origin. So to find r, that's easy. I square the first one. And remember, I talked about this in another lesson. When you have a two-part number here, like 2 root 3, before you go to the calculator, make sure that's in parentheses. So we're taking the first one and squaring it. We're taking the second one and squaring it. I can do that in my head. And then we're going to take the square root of that. So if I'm going to type that in on my calculator, and I don't have to, I could do that by hand for sure. But if I'm going to type it in on my calculator, it's parentheses 2 square root of 3, close parentheses, twice, and hit squared. You should get 12. Now, if that's bothering you, you can always square this and multiply them together. So 2 squared is 4, root 3 squared is 3, 4 times 3 is 12. If you're typing that in on your calculator, though, and you're having trouble, you type in the 2, you type in the parentheses, then you type 2, then you type square root. Now, the minute you hit square root, it's going to put a parentheses in there. 3, close those parentheses, and then close the big parentheses, and then square that. So 12 plus 4, square root of 16, r is 4. Okay? Oh, shoot. Now I have to figure out what my angle is. So I'm going to look at my situation here. And I know the tangent of the angle is opposite over adjacent. So 2 over 2 root 3. And I strongly recommend that you reduce that fraction. Makes it easier to put in the calculator. Just take those 2's and cancel them out. 2 over 2 root 3 is the same as 1 over root 3. And then when you type it in, it'll be second tangent 1 over root 3. Okay, so second tangent, 1 divided by root 3, and that's a 30-degree angle. Okay, so this little guy here is a 30-degree angle. That is not theta. Theta is here. So how big will theta be? Theta is 180 plus 30, so that is 210. So your number changed into polar form is 4 CIS 210. All this work was just getting this number into polar form. So guys, you still have to take it to the 6th power. We haven't done that yet. Okay. All right, so now we're going to do de Moivre's theorem to raise that to the 6th power. So we're going to take 4 to the 6th. Remember, you take the radius to the power. And then we're going to multiply the angle times the power. That's the way the theorem works. De Moivre's theorem says whatever your radius, whatever your r is, take r to the power, and then take the angle theta times the power. All right, so let's get our calculator out. 4 to the 6th, going to be a big number, 4096. And then we have to take the angle times the power. And that's 1260. Now that would be okay, except for one thing. Can you see what's wrong with it? That angle is way, way, way too big. So we have to shrink that angle down. So I'm going to have 1260. I'm going to subtract 360. It's still too big. So I'm going to subtract another 360. Still too big. So I'm going to subtract one more 360. And finally, it's the right size. Now, if you're having trouble keeping up, 1260 is too big. So I'm going to subtract 360 from it, and I got 900. That is still too big. So I'm going to subtract another 360, and I got 540. That's still too big. So I'm going to subtract another 360, and that's how I got 180. When your angle is bigger than 360, you just keep subtracting 360s until you get it down to the right size. This, then, is the polar form of the answer. Okay. Now, we also need the complex form of the answer. So you need to remember that what that means is x plus yi. This is our complex form. Okay? So here's r, here's theta. X equals, that x right there, equals r cosine theta, and y equals r sine theta. So 4096 cosine 180 is negative 4096, and 4096 sine 180 is 0. So when you write your answer in complex form, you can write negative 4096 plus 0i, because x plus yi, there's your x, there's your y, or if you prefer, it doesn't matter to me, you can just write negative 4096, because when you add 0, of course, it doesn't change anything. So here's my polar form, and here's my complex form. You can write it that way if you prefer. And that's the end of that assignment. Good job.